Then irrational numbers. Those are numbers that can't be expressed as a ratio of two integers, and written in base 10 have an infinite decimal representation. For example, the square root of 2, the cube root of 5, or pi. First, let's look at number bases of square roots. For example, base square root of 5. In this base, digits represent powers of the square root of 5. This base has a lot in common with base 5, because the square root of 5 raised to the power of 2 is equal to 5. The square root of 5 raised to the power of 4 is equal to 5 to the power of 2. In general, the square root of 5 raised to the power of 2n is equal to 5 raised to the power of n. So to express any number in base square root of 5, we only need to use the same digits as in base 5, that is, from 0 to 4. For example, 97 in base square root of 5 is written as 30402. This number, represented in base 5, is just 342. The digits that represent odd powers of the square root of 5 are all equal to 0. This will be true for any rational value. But in this base, we can also easily express irrational values that are multiples of square root of 5. For example, 1 to 3 in this base is equal to 8 plus 2 times square root of 5. Here, the digits representing the odd powers are not equal to 0. With the same logic, we can create number bases of higher roots. For example, the fifth root of 7. Fifth root of 7 to the power of 5 is equal to 7, and generally, the fifth root of 7 to the power of 5n is equal to 7 to the power of n. So in this base we can use the same digits as in base 7. 36 in base 7 is represented as 5, 1. To express this value in base fifth root of 7, we just have to write zeros where the powers of the fifth root of 7 are irrational. Like this, we can create a number base from any root of any number.